In this video, we're going to do some revision on parallel and perpendicular lines. Two parallel lines will have the same gradient. Often when we're working with parallel lines, we think of train tracks. So two parallel lines will always be the same distance apart and never meet. With perpendicular lines, they meet at right angles. What we're going to do in the video is start off by looking at some examples of parallel and perpendicular lines. So on the axis here, what we're going to first look at is the line now y is equal to x. So the f of x is equal to x or y is equal to x. We can see this has got a gradient of 1 and it passes through the origin. So it goes up 1 for every one it goes across. This is now the line y is equal to x plus 1. So again, it's got a gradient of 1, but this time it's cutting the y-axis at the point 1. This is now y is equal to x plus 2. These are all examples of parallel lines. We can see they're never going to meet and they've got exactly the same gradient. So y is equal to x is equal to x plus 1, and y is equal to x plus 2. They are parallel. What we'll now do is look at the most raw form of perpendicular lines. So this line right here is y is equal to 3. This one now is x is equal to 3. It could have been x is equal to 4, x is equal to 5, and so on. We can see these are meeting at right angles. These now are perpendicular lines. Other examples of perpendicular lines might be, for example, now back to y is equal to x. The perpendicular is now going to be y is equal to minus x. So we can see these two now are meeting at right angles. If we have a look at another particular line, this is going to be y is equal to 2x plus 1. This line right here, the perpendicular line through the same point here, is now minus 1/2 x plus 1. When we have perpendicular lines, we can write their gradients as follows. If we have the first gradient of one line, which we'll call m1, and we multiply that now by the other gradient m2, we will always get minus 1. This is the formal definition. If you have two perpendicular lines, when you multiply their gradients, you end up with minus 1. The way I like to look at it though is that one gradient is simply the negative reciprocal of the other. So for example now, if we had a line y is equal to 2x, the gradient of this line is 2. Therefore the perpendicular would be y is equal to minus 1/2 x. All we've done is turn this fraction over. Remember, that fraction is just 2 over 1. We've turned it over and made it negative. If I had, for example, now y is equal to 3 over 2x, then the perpendicular line would be y is equal to minus 2 over 3x. We simply turn the fraction upside down and multiply it by minus 1. So another one, y is equal to 1/5 x, then the perpendicular will be y is equal to minus 5x. So if we have parallel lines, the gradients are going to be equal. So we can say m1 is equal to m2 for a parallel line. For a perpendicular line, the gradients are the negative reciprocal. The easiest way to do this with lines is put them in the form y is equal to mx plus c. Once we have the line in this form, we can evaluate the gradient. The gradient is the m, and the c now is the y-intercept. So if you can put it in this form and simply evaluate the gradient, you're going to make your life slightly easier. Okay, let's work on some examples then. We're asked to find the gradient of a straight line that is a parallel to the line y is equal to 3 minus 2x. Let's first put this in the form y is equal to mx plus c. This is the general form of a straight line. So this one right here, y is going to be equal to minus 2x plus 3. So we can see that the gradient now is minus 2. Therefore the parallel line to this will have a gradient now of minus 2. We can see that once we put it in this form. Okay, we need to find a line now parallel to the line 2x minus 5y plus 1 is equal to 0. I'm going to rearrange this, and we're going to now write this as adding 5y to both sides. 5y is equal to 2x plus 1. I'm now going to divide by 5, both sides by 5, and we get y is equal to 2 over 5x plus 1/5. Therefore, the gradient now is going to be 2 over 5. That's the value of m, so the parallel line will be 2 over 5. On the next one, we want the perpendicular to the line y is equal to 3x plus 4. So this is in the correct form, y is equal to 3x plus 4. We can see now that the gradient is positive 3, therefore the perpendicular, and we can use the notation for perpendicular like so, is going to be equal to minus 1/3. All this is the negative reciprocal. This is 3 over 1, the perpendicular is minus 1/3. Okay, the next one, we want the perpendicular to the line x plus 2y minus 3 is equal to 0. So let's rearrange that. Let's first write now 2y is equal to, and I'm going to subtract x from both sides and add 3. At this stage, I'm going to divide through by 2, so y is equal to minus 1/2 x plus 3 over 2. All I've done is rearranged it in the form y is equal to mx plus c. We can see that the gradient here is minus 1/2. Therefore, and using the notation for therefore, the perpendicular will now be equal to positive 2. We're simply turning this fraction upside down and making it positive. Later on in your studies, you'll write m1 multiplied by m2 is equal to minus 1 for a perpendicular. But all we need to do is recognise that we turn the fraction upside down and multiply it by minus 1. Okay, write down the equation of the line perpendicular to each of the following lines which passes through the same point on the y-axis. So if we just think about this line now, what we've got is the following. We've got y is equal to 2x minus 1. If I just draw a quick line now, or a quick sketch of this, what we're going to have is the following. So let's grab this up and we will use that one. This is going to have a gradient of 2 and it's going to cut the y-axis at minus 1. So it's going to look something like this. The perpendicular through the same point will look something like so. So it will be at right angles through exactly the same point. So we know that it's going to go through now minus 1. So what we can do then is say that the gradient of the perpendicular is going to be minus 1/2. So we'd have y is equal to minus 1/2 x minus 1. Okay, this one, y is equal to minus 3x plus 1. So all we need now is the negative reciprocal, and this one is going to be y is equal to positive 1/3 x, and it's going to go through the point of positive 1. So if we wanted to draw a quick sketch of that, what we'd have is the following. So let's do that one. Now we've got minus 3x plus 1, so that's going to look something, give or take, like so. So we're going to be cutting through here at positive 1, and then the perpendicular will now be, and if we put that on, the perpendicular looks something like so. So remember, these are at right angles. Okay, and the next one, what we've got is y is equal to x plus 2. The negative reciprocal, remember, this has got a gradient of 1, or you might want to say just 1 over 1. Therefore, the gradient of the perpendicular will be minus 1 over 1. So the equation of the line will be y is equal to minus x plus 2. Don't be surprised if you see that written as y is equal to 2 minus x. Okay, let's look at a couple more before we move on. So this one right here, we would have now y is equal to minus 2x plus 3, or 3 minus 2x. On the next one, y would be equal to minus 4x minus 3. This one would be y is equal to positive 3x, and then the next one, y would be equal to positive 3 over 2 x minus 5. So these are the perpendiculars going through exactly the same point. Okay, let's move on. We need to find in the form y is equal to mx plus c, so the straight line equation, the equation of the straight line A parallel to the line y is equal to 4x minus 1, which passes through the points with coordinates 1, 7. Okay, this part of the video requires you to understand how to find the equation of a straight line. We can do this anyway. Straight off, we can see that the gradient, which is our m value, is going to be equal to 4. There are two different ways of finding the equation of a straight line. All we need is a gradient and a point that it goes through. So we've got the gradient and we know it's parallel, and then we've got a point that it goes through, 1, 7. Often at GCSE it's taught now given y is equal to mx plus c. What we do is plug the values in. So we can see here y is 7. So 7 is going to be equal to m. We know that's going to be 4. And then we multiply this by the x coordinate, which is going to be 1. And this gives us now plus the c. So subtracting the 4, we can see that 3 is going to be equal to c. So all we need to do is put this back together. So y is going to be equal to, the gradient is 4, so we have 4x plus 3. So this now is the equation of the straight line going through the point now 1, 7 with a gradient 4. I'm assuming that you're pretty cool with this and have done this before. Alternatively, you can do y minus y1 is equal to m, the gradient x minus x1. This is another method that's used at GCSE, but more often than not at AS and A level. It's entirely up to you. I prefer working with this one, but it's entirely up to you. So in this particular case, we would have y minus 7 is equal to now 4, which is a gradient, which we've got here, and then we'd have now x minus 1. So what we'd have now is y minus 7 is equal to 4x minus 4, and then we'd simply add the 7 to both sides. So y is equal to 4x plus 3. So that's the parallel line through the point right here. Okay, we need the perpendicular now to the line y is equal to 6 minus x, which passes through the coordinates negative 4, 3. Okay, so let's just rearrange this. Let's put this in the form y is equal to mx plus c. So on this one, what we've got now is y is equal to minus x plus 6. Therefore, the gradient of the perpendicular is going to be positive 1. So what we'll have then is m1 is going to be equal to minus 1. Therefore, m2 is going to be equal to positive 1. So we've got now a gradient. So what we've got is m2, the gradient, and then we've got a point that it goes through, which is going to be minus 4, 3. So let's write this out then. If we want to use y is equal to mx plus c, so y is equal to mx plus c. So we'll plug the numbers in. We're going to have 3 is equal now to the gradient, which is going to be 1, multiplied by the x coordinate, which is going to be minus 4, and then we get the plus c. So adding 4 to both sides, we can see 7 is equal to c. And then all we need to do is put all this back together. We found the value c, so y is going to be equal to now 1x. So we can just write x plus 7. So that is the equation of the line perpendicular to y is equal to 6 minus x, which passes through the point negative 4, 3. If you wanted, you could use y minus y1 is equal to m, the gradient, x minus x1. So all we'd do is write this out. So we'd have y minus 3 is equal to the gradient, which is 1. Then we'd have x minus 4, which is going to be plus 4. So we'd have y minus 3 is equal to x plus 4, and we'd simply add the 3 to both sides. So y is equal to x plus 7. So either way round, and you can decide on which way you prefer. Okay, the line with equation 2x minus 3y plus 5 is equal to 0 is perpendicular to the line with equation 3x plus ky minus 1 is equal to 0. We need to find the value of the constant k. What I'm going to do is put both of these in the form y is equal to mx plus c. So if we look at the first one now, we can write this, add in 3y to both sides. 3y is equal to 2x plus 5. I'm now going to divide both sides by 3, so y is going to be equal to 2 over 3x plus 5 over 3. So the gradient of this line right here is 2 over 3, or 2/3, and that's a positive gradient. If we now rearrange this one right here, what we're going to have is the following. And I'm just going to rewrite this in the form y is equal to mx plus c. So what we'll have then is the following. We will have ky. Now I'm going to subtract 3x from both sides and add 1. So we'd write this now as minus 3x, and then we'd have plus 1. Dividing through by k, y is equal to minus 3 over k x plus 1. and that would be over k. Okay, so what we've got now are these two lines. We're being told now that the second line, or this line right here, is perpendicular to this one here. So these two are perpendicular. Therefore, if we consider the negative reciprocal of this, what we're going to have, the gradient of the perpendicular, so we can say, therefore, m of the perpendicular will be equal to minus 3 over 2. So if we now just equal these or equate them, minus 3 over 2 is equal to minus 3 over k. Therefore, from that we can see quite clearly k will be equal to 2. So that's quite a nice exam question where you're just looking at the different gradients. Okay, A is the point 1, 5, so that's just there, and B is the point 3, 3. We need to find the equation of the line parallel to AB passing through 5, 9. Now, finding the gradient, you can do this, and I'm assuming to some extent you've looked at this before. If we look at the gradient right here, we can either do it visually and see now that it's going to be minus 1, or we could simply put this through and find the gradient. The gradient, m, is the change in y, so the change in y, that should be in, it looks like in, over the change in x. So if we look at this point right here, what we'll do is the following. We will do now 5 minus 3, so what we'll have then is the change in y, 5 minus 3, divided by it now 1 minus 3. So 1 minus 3. So what we're going to get here now is that's going to give me 2, that's going to give me minus 2, which gives us a gradient of minus 1. So we've got a gradient, so we can say m is going to be equal now, let's put this here, m is going to be equal, in fact let's just write m is equal to, rather than put it in brackets, m is equal to minus 1, that's the gradient of the line. So m is equal to minus 1. We've got a point that it goes through, which is going to be 5, 9. Therefore, what we can write now is the following. Y is equal to mx plus c. So 9 is going to be equal to minus 1 lots of now 5 plus c. So let's do that then. Let's rewrite this. We can add the 5 to both sides. So 14 is going to be equal to c. So y is going to be equal to minus x. Remember, m, the gradient is minus 1, plus now minus x plus 14. Or we could say y is equal to 14 minus x. And that now is the equation of the line parallel to AB passing through 5, 9. We need to find the equation of the perpendicular now to AB passing through the midpoint. Now midpoint, we can see again that that's going to be 2, 4 from the graph. Alternatively, we could find the midpoint by adding the x's together and dividing by 2, and adding the y's together and dividing by 2. So if we add the x's together, we're going to get 1 plus 3 over 2. If we add the y's together, we're going to get 5 plus 3 over 2. More formally, it's written as x1 plus x2 over 2, comma y1 plus y2 over 2. All you're doing is adding the x's, dividing by 2, adding the y's, dividing by 2. We can see on here it's nice and straightforward, but if we didn't have a graph, we'd need to do that. So that's going to give me now 2, and then we're going to get this point, which is going to be now the 4, which is this point just here. So we've now got a point that it goes through, and that point is going to be just here. So let's just mark this on. So what we're going to have is something looking like so. So this is now the straight line, and it would continue. What we're going to end up with is something looking like that, and that too will continue. So let's write this out then. The gradient of this now is going to be positive 1, as it's the negative reciprocal. So what we can say then is m2 is going to be equal to positive 1. If the gradient of AB is minus 1, then the gradient of perpendicular is going to be positive 1. So y is equal to mx plus c. So all we're doing is putting this in. So what we're going to have then is 4 is equal to 1 lot of 2 plus c. So we can see through here that c, subtracting the 2 from both sides, c is going to be equal to 2. Putting all of that back together, y will be equal to 1x, which is just x, plus 2. And of course, if you continued that line, that's what we'd end up having. So we'd have this line and it would look something like so. So if we continue that line, it would look like that. And we can see now that's got a gradient of 1 and it's going to cut the y-axis at 2. So there we go, some basic revision on parallel and perpendicular lines. The take-home point is if you have parallel lines, they're always going to be the same distance apart. They will never meet and their gradients are the same. If you have perpendicular lines, they're going to meet at right angles. And if we have one gradient, then the second gradient is going to be the negative reciprocal, or you simply turn the fraction upside down and make it negative.